Good afternoon, everyone. Welcome to our CIVICA Data Science Seminar Series. And it is my honor today to introduce our today's speaker, Dr. Michelle Torres, who is an assistant professor of the Department of Political Science at Rice University. Michelle's interests lay in computer vision, causal inference, and survey methodology. Substantively, she focuses on political communication, participation, and psychological traits. And her research focuses on making statistical and computer science methods accessible to political scientists. She also develops and applies innovative and rigorous tools to achieve a better understanding of social issues, especially in the fields of political behavior and public opinion. She's going to present today her research project, Framing Protests, Determinants and Effects of Visual Frames. And I just want to quickly remind everyone who is with us today that this session and the seminar is being recorded. And Michelle, the floor is yours. You can share your screen. Thank you. Michelle, you muted, sorry.
Of course. Again, after 2 years, I still haven't mastered that. Is that okay now?
All good, yes.
Perfect. Okay. So first of all, I have to say thank you so much to Olga for inviting me, to CIVICA for hosting me, and for all of you who are here to listen what I have to say about protest and the way in which media frames them. Today, I'm going to talk a lot about images and visual content. This project, it's a long-term project that actually spans over 3 articles, and I'm gonna talk a little bit about each of them during this talk. I am interested basically in how to extract content from images and photos of political events, understand what kind of visual messages are implied in these pictures, to then check what determinants or political factors are determining what we as an audience see, and finally how those visual elements affect the formation of political attitudes and opinions. So I'm really looking forward to your comments, feedback, reactions, so please feel free to engage with that. So just to give you a bit of the motivation behind this project, I'm going to show you these headlines that were published in May 3rd of 1963 in local US newspapers. These headlines are talking about a protest that happened in Birmingham, Alabama, in the context of the civil rights movement. If we read some of them, hundreds held in racial show, nearly 700 arrested as 2,000 watch, we get a bit of information of what happened during these events, right? If we go back actually and read the article, the first article of these headlines, we get a similar flavor. Apparently, there were a lot of people in this protest. There were some arrests, but beyond these arrests, the text generally said that the protests were pretty peaceful and that there were not a lot of eventful things to report. However, this is the image that the New York Times posted in its front page when talking about this protest. And this image is telling us a different story from what we could get from the text. This is a very violent depiction of a dog attacking a teenager, apparently under the command of the police. And although there's a full story about the background and the story of this picture, I want you to focus on what you're seeing. And beyond the feelings of impotence and anger that this picture might trigger, the important thing for me is that it's exactly putting under the spotlight the demands, the main demands and like complaints of the civil rights movement, which is discrimination and violence against African Americans. A very powerful picture that is considered to be a catalyzer of the movement, of the civil rights movement. First of all, because it reached international audiences and communicated a bit about the things that were happening in terms of racial tension in America in a moment where the US was trying to win hearts and minds abroad. Internally, it also mobilized elite and public opinion that slowly started aligning more with the movement's demands and that started pushing for policy change, which in my view, it's led to one of the biggest transformations, if not the biggest transformation in terms of policy and political landscape in the United States. So one picture with this enormous ability of changing hearts, changing minds, and triggering a lot of positive change. And this is, of course, not limited to images in the US. We can also think about images like this that are very relevant in the international landscape, about immigration, about war, about poverty, that are able to mobilize people in the right direction. But I don't want you to think that the impact of these images is limited to these very intense and powerful images. Actually, we can have other milder ones like this one, which was published or like posted by Barack Obama in a tweet right after the nationalist protest in Charlottesville, paired with the quote from Nelson Mandela that no human being is born hating another human being on the basis of its skin color, background, or religion. So a very powerful and cute image conveying this nice message of unity, diversity, while also portraying the very charismatic personality of one of its actors. So the main takeaway from these pictures is that they can help us to tell a story, and more specifically, they can help us to frame a story. And these visual frames are going to be critical to understanding media communication. First of all, because images are very powerful drivers of emotions that in turn shape cognitive processes, deep cognitive and unconscious processes that eventually lead to attitude formation and attitude change. Further, image processing is way easier than other sources like text that require more skills and sophistication like literacy. But for me, the most important thing is that images can provide information that goes beyond language. We are using images to tell different stories, to frame stories in different ways. And just to be clear what I mean when I say visual frame, I refer to these visuals that an actor uses to relay information and that reveals what she wants you to see, what she considers important from a particular event to communicate to you. This is connected to the idea that content matters, of course, what's implied in these images matters, but also how that content is presented is also going to be important to frame a story. So to give you an idea of how these visual frames operate in the real world, I'm going to show you 4 different newspaper covers that were published in May 30 of last year. They are talking about the protest that happened in the context of George Floyd's death. And the interesting thing that these front pages have is that they all have the same text taken from a newswire source, the Associated Press, but the different things between them are just the picture and the headline. So in this case, we see the protesters gathering at night, but in a very peaceful manner, just like listening or like organizing in the crowd. Here we see a bit more of tension, right? There was a strong police presence there and a heavily armed police presence. Here we see already some tension between this heavily armed police and the protesters. And here we see absolute chaos, definitely the culmination of a really violent night. So the main takeaway from these pictures is that they are not only telling us different stories, but more like different parts of the same story. And this is what I mean when I'm talking about this visual framing. So this leads and motivates my questions for this project, this big project that I have, which is how can we identify and measure this visual framing, whether political factors like ideology are associated with the generation of the visual frames of protest, and finally, whether visual frames impact opinions and attitudes towards social movements. And this talk is going to be heavily focused on the second and third question, but in order to understand part of that question, I need to talk a little bit about the first one, and because I know you are all a Method C crowd, I will talk to you a bit about the method that I'm using to identify visual framing. So how can we identify and measure visual framing? If I want to answer that question, I need to tell you a bit more about the challenges in the analysis of images. And first of all, we need to remember that we are constantly bombarded by images. We have these large amounts of pictures and photos that really complicate and slow down the task of coding and classifying them. But even if you manage to get an army of research assistants that can classify and code your pictures, then we have the problem that it is really hard to define and standardize coding schemes. But even if you do that, then you face the challenge that coding images or classifying them is very sensitive to coder subjectivity and cognitive filters. But if you look at all of these challenges, then you realize that they are very similar to the challenges that we also face with text, and yet we have managed to overcome them in that area. So my question here is whether we can do something similar to what we do with text, use similar methods, but now with images. And the answer is, well, maybe we can emulate the very popular bag of words that helps or is the basis for multiple analysis in text analysis, and have something like a bag of visual words. And the bag of visual words for images, it's a tool that I am borrowing from computer science, which is basically a series of steps to reduce the dimensionality of the image, tokenize them, and make them interpretable for further analysis. It consists on identifying key points in the images, extracting features from these key points so the computer can understand what like a collection of pixels mean. And then we're going to create a visual codebook, because unlike text, we don't have words or sentences or n-grams that we can take as tokens. And finally, we're going to build an image visual word matrix that is going to be very similar to the document term matrix in text. So the key point detection step is very intuitive. We're just interested in identifying salient regions, edges, and corners in the image. There are multiple ways of doing it. I am using a fast hashing, which is very popular. And the idea is that once you identify these key points and you plot them, in this case, for example, with green dots, you can definitely see that the key points are aligning along the edges of really important features. And these features tell us something about the objects that we're finding in these images, and these objects are in turn telling us something about the content or the underlying message of the picture. Once we have these key points, we're going to use a descriptor to extract features from them. Multiple ways of extracting the descriptors and extracting features. I'm here also using a very common and popular one called the root sift. And the idea is that I am defining this feature extraction process in the following way. I am defining a feature as the change in pixel intensity in a grayscale image. And I'm going to quantify this change in pixel intensity with a gradient magnitude and orientation. Basically, a histogram of gradient magnitudes and orientation. So the way in which it works is that if I have a picture and then I have all of my key points like here, let's focus on this guy, this little guy surrounded by the red square. We are going to take that key point. We're going to take the 16 times 16 pixel neighborhood around that key point. We're going to overlay a grid of 4 times 4 cells in this neighborhood. So we're going to have 16 cells in the neighborhood of this key point. And then in each of these cells, we're going to do the following. We're basically going to see how the pixel intensity is changing along the X and along the Y direction. So in this case, along the X direction, if we focus on this pixel, we see that there's no change because it's coming from white to white. But in contrast, if we focus on the change in the Y direction, we see that this is the strongest change that it could happen from 255 to 0, from white to black, right? So we are going to represent all of these pixel intensities in each of our cells with vectors or gradients telling us how is this pixel intensity changing. And then we are going to represent or summarize all of these changes and magnitudes with a histogram. The histogram is going to have in the x-axis all the possible orientations collapsed into 8 bins. And then the height of the histogram is going to be the magnitude of this change. So the idea is that for each of these cells, we're going to have a histogram that we are then going to flatten or concatenate. And at the end, each of the green key points that you saw in the pictures is going to be represented with a vector of 128 elements corresponding to 8 bins per histograms times 16 cells. So once we have these features extracted for each of these key points, then we need to define our visual vocabulary. And again, this is important because if you think about images, we are not able to find very concrete tokens. We can't say like in text, oh, this is a word or this is a sentence. So we basically need to create or provide some references to identify some of these features. So what we're going to do is like, this is a cartoonish example. Suppose that I identify those key points in the images. I extracted the features, meaning a vector of 128 elements per key point. I am mapping them into my multidimensional space, and then I'm going to cluster all of these features, and the centroid of each cluster is going to represent my visual word. Why am I doing this? So if now I'm able to see you all guys and take pictures of your faces, and then I apply these key points, I'm probably going to find like little pieces of eyes and noses and mouth. The thing is that in images are just like in real life, right? Like my eye is going to be really different from Olga's eye, or my nose is going to be really different from Hui's nose. And the idea with clustering is that we take the average of like this concept. Like we're saying, well, this cluster of patches, they are different, they are not identical, but they look similar. They are like following a very similar pattern in terms of pixel intensity change. So I'm going to take the mean of that cluster, and I'm going to use it as a reference of what it could represent a nose or an eye, for example. So mathematically, a visual word is the centroid of a cluster, right? So it's also a 128 element vector. Intuitively, it's a cluster of mini patches. It's like the cluster of the neighborhoods around the key points that we extracted, and that all belong together or that have the same membership to the cluster. So this is a visual word with crowds, like pieces of crowds or dense groups. This is a visual word with pieces of signs from the protest. And this is a visual word with like close-up images, right? We can see more faces and we can see like body parts. So now that we create our visual codebook, we can create our image visual word matrix that is the basis of this bag of visual words. Just as a reminder, the idea is to emulate the document term matrix in text, and this is how the document term matrix in text looks like. We have text in rows, we have the words that appear in each row in the column, and then we're going to count the number of times that each of these words in the columns are appearing in the rows. So in this case, black appears 1 time here, matter 1, in this case protest, it's appearing 2 times in the second row, etc., etc. So the idea is to have to emulate this document term matrix, but with the images in rows, the visual words that we created in columns, and then to see how many times each of these visual words is appearing in each of the images. So once we have that matrix, we can basically do whatever we want with it. I wouldn't recommend anything like oriented to a very specific or concrete supervised issue or supervised classification problem, because there are other tools that are much more suitable for that. But if, for example, you want to do something unsupervised or that requires, or that you are envisioning more like a clustering or like a topic model thing, then it would be perfect. And I'm going to give you an example. So quick refresher, we build a big, the bag of visual words approach reduces the dimensionality of the pictures. We extracted features and turned them into visual words that serve as reference. We build this document matrix, term matrix style input. And then what I'm going to do in my particular case to measure or to identify visual frames is that I am interested in identifying topics in my images. And for that, I'm going to use a structural topic model, very popular among political scientists because it was created by political scientists, and it's awesome. It's an awesome method. And it's a tool for topic modeling of text that includes document level covariate information. It's basically a mixture model, very similar to a latent Dirichlet allocation, an LDA model. And it gives you probability that words belong to each of the topics that you are interested in or that you identified. And the nice thing is that it's not a single classification outcome, right? Like you have proportions for all the potential topics in your corpus by document. So the idea is that if you have an image and you run structural topic model and you find, let's say, 6 topics like sky, crowd, pavement, and flag, then you will be able to have a proportion of each of these topics per image. So you are not just going to say, oh, look, you're not going to run a classifier to say this is a crowd or there's a flag in here. You're also going to get the proportion of these topics that we are finding in the images, and I will be equating these topics to visual frames. So once I have identified and measured these visual frames, I can proceed and answer the question of whether political factors like the ideology of the news outlets are associated with the generation of visual frames. And I'm going to focus on a dimension of framing, which is the mood and environment of a movement. Here we can see how this might be operating. You have these gloomy, dark, kind of tense environment with some clashes between the police and the protesters, or at least some anxiety and some tension between them. Whereas in this picture at the bottom, you have this crowd, open space, very colorful, happening in the middle of the day, that is probably more inviting. And these differences are actually relevant because the literature in social movements and political geography puts a lot of importance of place and context in shaping protest actions and in shaping protest success. So night, for example, is considered a politically dangerous and impractical time space. I know that night it's a time of the day, but because of its characteristics, it also shapes the space in which a particular event takes place. And it is considered dangerous and impractical for multiple reasons. First of all, logistics, right? It poses some challenges because the buses are not running that often, because you have your kids at home and you don't have a babysitter to look for them, etc., etc. It also, night is also associated with these feelings of vulnerability because it's dark and you can't see, and then you feel like you're clumsier and then you are not as sharp. It increases your feelings that you're unsafe and you're not able to protect yourself. And finally, there's also like this very natural association of night and crime, you know, like when the sun goes down, the criminals come out. So for those reasons, we, well, the literature considers night to not be a great time space for protest success because it discourages mobilization. And the question here is like, well, who is interested in discouraging mobilization or portraying this protest as more negative or as more unsafe? And the literature and in media communication and social movements also points out that the conservative outlets are more likely to do so because protests do not align with principles that are typically considered conservative, right? Like the preservation of the status quo, law and order, and patriotism. So here my expectation is that more conservative news outlets are going to have higher incentives to depict protests as dangerous and risky with the idea of discouraging mobilization, and therefore they are going to use a higher proportion of a night activity frame. And to test this expectation, what I did is that I collected around 2,000 images from 3,500 front pages of local US newspapers during the Ferguson riots and now during the new wave of protests related to George Floyd. I have these 3 dates for the Ferguson riots in 2014, and for the BLM protest now in 2020, I collected these front pages from May 29 to June 2nd. The bag of visual words that I created, well, I'm using the approach, and first of all, I am creating a codebook that I generate from 20,000 images or around 21,000 images from Getty. Why am I doing this? Why am I using all of these images from Getty with the label or tag protest, like Black Lives Matter protest? My idea is that I want my codebook to be very comprehensive and to include as many frames as possible. And because Getty collects all of these images from multiple photographers, multiple sources, and multiple organizations, my idea is that they are basically increasing the chances that we get the full picture of what happened during those days. So basically the idea is that if we were going to stitch all of these images from Getty together, we will get a really good picture or image of what happened during those protests. So then I'm creating this codebook based on that sample, and then I'm going to have a separate sample with my images from my front pages that I will compare to this codebook to see what like the proportion of those frames are happening in my corpus of interest. And for that, I run a structural topic model with 15 topics and ideological slant and year as prevalence covariates. I am interested in one, testing whether ideology has an impact on this generation of visual frames. And I'm using year to see if there are differences between the 2014 and the 2020 protests. And some of the topics identified are crowds, fire, smoke, individuals, police signs, but I'm going to focus on this visual frame of night activity that I talked about in the previous slide. So if I tell STM to give me the most representative images per topic, this is what I get. And as you can see, this means that these images have a high proportion of the night activity topic or of the night activity frame. And you can see what the computer is seeing, right? It's looking at dark backgrounds and basically like splashes of light on top of dark backgrounds, like in this case, the fire or the smoke or the lights. So that's what the pixel intensity change pattern is like what the computer is picking up from these images. So here in this graph, I'm going to put the newspaper in the x-axis, and in the y-axis, I have the mean proportion of topic night activity for all of the pictures that these newspapers had in their front page in both waves of the protest. And as you can see, there's like an important variation. The Newsday is basically posting images with almost 0% of topic night activity, meaning they are probably publishing just the images with daytime protest, whereas the Washington Post has a much higher, more than 20% of their pictures have this night activity frame. If I analyze and test this expectation of the correlation or the relationship between this variation and ideology, here is what I get. In the x-axis is ideological slant of the newspaper, ranging from liberal to conservative. On the y-axis is the mean proportion of this topic night activity for all of the pictures that they published. And as we see here, there's a positive and reliable relationship between these two variables, indicating that the more conservative a newspaper is, the higher the proportion of night activity topic they are going to use in their photos, in the photos they publish about the Black Lives Matter movement. This, of course, and all of this theory that I talk about is assuming that we have left-leaning protest. So now I jump to the question of whether visual frames impact opinions and attitudes towards social movements. And for that, I'm going to focus in another dimension or another element of the mood and environment frame, which is violence. And visual violence is particularly important beyond time space for protest mobilization and for protest success, because it builds perceptions of legitimacy. It has this potential of activating emotional responses, motivate unconscious reactions of anxiety, opposition, empathy, or denial. So it's like a crucial thing considered as an element that shapes people's opinions towards social movements. And I'm going to focus on two elements here, on whether the protest is depicted as violent versus peaceful, but also if it's violent, what's the source of the violence, if it's a protester or if it's the police. And I have like several hypotheses here based on like this combination of violence and source of violence. Basically, I'm expecting that if there's a violent, if you see a visual, if you see a violent picture of the protest, you are going to be more likely to have a negative opinion of it if the violence is committed by the protester. But you might sympathize more with the movement if the violence is committed by the police. This is operating in this way. If you see more violence committed by the protester, you think that you have a higher likelihood or chance of getting arrested. So that increases your costs of joining the movement or sympathizing or supporting them. Whereas if you see violence by the police, you, based on repression theory, you think that then that's going to make the objectives of the protesters more achievable, because you can put some pressure on the government to attend their protest. Their demands. Also, if you see more violence by the protester, you are going to be less likely to identify with them, because then you're going to see them as an outsider. It's like, no, I'm not a violent person. I'm not identifying with them. But in contrast, if you see violence by the police, then there's repression theory also tells us that there's more likelihood of feeling empathy or compassion for the victims, which in this case is a protester, and therefore you're going to share their views in a higher degree and sympathize more with the movement. So to test this hypothesis, I have a sample of 2,000 respondents from Lucid. Basically, I did a survey experiment where I provided my respondents with a newspaper article about talking about multiple protests happening throughout the country that turned violent. Important thing here, I am not using the Black Lives Matter movement for this example. I am using the Occupy Wall Street movement protest, basically because in the moment where I was trying to do these experiments, people were overly treated with images, text, news about the Black Lives Matter movement. So their positions were basically already determined by all of this content. Whereas with the Occupy movement, it was like some time ago, so people didn't have it so fresh in their minds. Some of them didn't even know what it was, so it was a good example to actually test how this visual content and verbal content is shaping opinions. So I have a control condition that is just giving the respondents the vignette with the text. And I have different treatments. One that includes a picture with no violence, so no visual violence treatment. Then I have a picture that includes a violent protester, and then I have another picture that includes a violent police. And I have several outcomes to evaluate these negative or positive attitudes toward the movement, and oriented towards evaluating people's evaluations of the police response, perceptions of success of the movement, identification with the protesters, and also future engagement, with the idea of like measuring how much these things are affecting participation. So this is the vignette from the control condition. It's trying to emulate this newspaper article without identifier of where it's coming from. And it just has a text, again, mentioning that there were several protests and that they went by. The peaceful protest condition has exactly that same vignette, but it also had embedded a peaceful protest image, which is this one. The violent protester condition had this one embedded, and the violent police condition had this one as well. And here are the results. In the x-axis, you will see the treatment effect. In the y-axis, you will see the different outcomes that I had. And for the different outcomes, I just basically asked my respondents how much they agreed, or how strongly they agreed with several statements, including, hey, the movement is going to achieve their objectives. I share the views with the protesters. I will get involved with a similar movement to this movement, and the police went too far. So level of agreement with these statements. And all of the results that I'm going to present here are based on the control condition as the baseline category. So as we see here, the violent protester and the violent police conditions are having a negative effect on the perceptions that the movement will achieve their objectives. And it's interesting because even though this violent protester condition is confirming my hypothesis that a violent protester is going to make your opinion more negative in multiple dimensions about a social movement, the result from the violent police is going against what I was expecting. And you will see that same pattern throughout the results. So the violent police and the violence protester has in general a negative effect in almost all the outcomes I have. So regardless of who's committing the violence, either the police or the protester, people tend to have a more negative opinion of the movement and are less likely to engage with it. So this suggests that it's more a theory of costs. If you know that you can get hurt, or if you know that you can get arrested, regardless of whether it's fair that the police is attacking or not, then you're gonna be more hesitant to support the movement. However, something interesting here is that the protester pays a higher cost for being violent, whereas the police still has the benefit of the doubt. And that's something that I also see in the pilots. Like when you put up an image of the violent police, people's first reaction is always like, but we don't know what happened before that. Like there's always this tendency to believe that the police has a monopoly of the force, and that they are justified to sometimes act in violent ways because the protester might deserve it. So this is what I'm finding in general. The only result that it's kind of in line with what I was expecting is this one. If you see the violent police frame, then you're more likely to evaluate the response of the police as too extreme or going too far. And also here you can't see it, but some of these differences, most of them between violent protester and violent police, are also reliably different from zero. So that we are definitely finding these differential effects there. So just to conclude, images are powerful and abundant elements of frames. The measurement and analysis of these components are crucial to have a better understanding of how political communication and attitude formation are interacting. I find that conservative outlets are more likely than liberal outlets to depict protest in more dangerous and riskier time places. And I also find in the second study that the visual portrayal of the source and level of violence in a protest affect attitudes towards the movement. So coming soon, I also want to see what's the interaction between text and images. If you provide more information through text or through the image, people's responses are different. My hunch is that the image is just a heuristic that people are always gonna take, like because it's more like a see to believe, are gonna put a higher weight on how they build their perceptions. But I'm also interested on the mechanisms behind this attitude formation. And because of the pandemic, I had to stop some projects, but the idea was to use some eye tracking technology to really see what people were focusing on when they were digesting these images. I need to do some heterogeneous treatment effect analysis, but I need bigger samples, and also to focus on other types of protests. As I said, this was all assuming a left-leaning protest or with left-leaning objectives, but it will be also interesting to see whether the topic, if it's, for example, nationalism, actually affects the way in which conservative news outlets are covering those events. Sources of images, social media versus regular media, and also measuring media bias. And with that, thank you so much for your time and for your attention, and I will look forward to your comments and questions.
Thank you so much, Michelle. We have one question in the Q&A session so far. Well, it's like several questions actually from Fahrat Miller. So what do you think about the relationship between the visual content and the headline of the news article attached with it? And do you also take into account the political leaning of the newspapers themselves?
So for the first one, I honestly haven't done anything with the headline yet, because in this case, sometimes my impression is that it didn't provide that much information, or was generally pretty much in line with what the main text was saying. So I don't have a lot of evidence, or beyond my anecdote, like checking all of these newspaper covers. But my impression was that it was definitely the really contrasting thing, or the ways in which we could see more and more variation or stronger differences was with the picture. But that's something that I've been talking to Olga a lot, right? Like how are these things working? If we were to train an algorithm to describe the image, whether we could get something similar to the caption or the headline, for example. And I don't think we will get something very similar. It's also going to be a lot of variance there, and something that it's not very factual, but more editorial. But that's what I can say about that. And for the political ideology of the newspaper, yes, the measure of ideological slant is actually a measure of political ideology of the newspaper. It's basically, and I'm saying political ideology because it's constructed based on this method by Gansco and Shapiro, in which they are trying to compare how these newspapers are talking when they are publishing news articles, and compare that to how Democrats and Republicans in Congress talk. So basically it's trying to, it's based on like these similarity measures of how politicians from the left and from the right and from the liberals and conservatives are talking, to map newspapers into that language. So it is a measure of political ideology of the newspaper.
Okay, thank you, Michelle. We have another couple questions. First block of questions is from Ken Benoit. So could you please explain again, how are the images parsed into visual words? And also, even more than words, visual tokens. Visual tokens are contiguous with other potential words and two-dimensional, not just linear space. And is this contingency and context used in any way?
Sure. So I can go back to how we're tokenizing the images, basically. If my PDF allows it. Okay, so here it is. So the idea is that first we're going to identify the key points, and this is actually for Ken, this would be like almost like a stop word removal, because we might not be super interested in a lot of the background, or a lot, like if you're taking a picture with a green background in the back, then you might not be interested in checking absolutely every single area of that background. So the idea with this key point identification is to get like a cleaner first step for the feature extraction, and also to make the process a little bit less burdensome in terms of computational power. So once you identify the key points, then you focus on each of these key points. This one, for example, is one of them. We take the neighborhood around them, the 16 times 16 pixel neighborhood around each of these key points. We put this grid on top. And what we're going to do is that for each of these grids, we're going to focus on how the pixel intensity is changing. So this red square is basically a filter that is going to slide throughout the cell. And we're going to see at each of these pixels, we want to see how the pixel intensity around it is changing from in the X direction and the Y direction. So this is just basically like if you have a corner, for example, the pixel intensity change is going to be very, very specific. And it's going to be very similar to other corners that you find in the image. So to represent this pixel intensity change in this cell, we're going to use these vectors, right? So in this case, this vector is telling us basically all the pixel intensity change in this cell is happening downwards, right? And it makes sense. It's coming from from white to black. So then we're just going to collapse the information about that pixel intensity into these histograms, and we're going to concatenate them for each of these key points. So that's a feature extraction. For the actual token, what we're going to do is just going to cluster all of these features. And granted, that's something that I should have said before. There's a lot of discretion on how many key points, for example, you want, how many clusters you want. But the centroid of each cluster is going to represent that visual word. So it's going to be, the visual word is represented by a vector of 128 elements. And when we analyze what type of mini key points belong to each cluster, we can actually build these visual words intuitively, or we can visualize them. So these were all the pictures, all of the mini patches belonging to one of the clusters. And the centroid of that cluster was the actual input that we take to estimate the differences between the key points and the visual words. I don't know if that makes sense.
Okay, well, I guess if there are going to be some additional questions from Ken, he probably will put, oh, okay. So, well, he has additional question. Is the size of this clustering or the key point identification process something that has to be adjusted for each image?
Not for each image, but for each corpus. And in the code that I develop, actually, because I'm borrowing all of this from the computer scientists, but it's impressive how little they care about some of these decisions. So in the code that I develop to share with social scientists, I actually add an extra step where you basically test different sizes of key point detection. The key point detection, if you change the Hessian threshold, you will be able to detect more or less. So if in your particular problem, you care about retaining much more information and many more key points, then you can change that parameter to your particular objectives, but not at the image level, but at the corpus level. If you instead care much more about like very salient objects, then you can increase that threshold and just retain a lower amount of key points. So that's one decision that you can make at the corpus level. For the clustering, it's the same. I always say that like substantive knowledge really needs to guide this, and like a deep knowledge of your data. So sometimes if your idea is like you have a very good idea of what you're expecting to find, let's say crowds, like the topic of crowd in the image, then maybe you don't need that many clusters of that many visual words, because they are going to pop out like really easily. But if maybe you are more interested in finding distinction between crowd day and crowd at night, then you probably need to increase the size of your vocabulary, the size of clusters that you have in the clustering step, to get more of this variation, or to capture a bit more of those differences. So there's definitely some discretion there, but everything is happening at the corpus level. And the nice thing is that you can always visualize it, right? Like you can always get the visual vocabulary and go back and see what kind of visual words you're getting. You can always go back and like run some elbow plots to visualize an optimal number of clusters naturally. And I think that's a very strong feature of this method, because I am fully aware that this is very far from being a convolutional neural network, and I get a lot of pushback for that, but this has the super nice advantage of always tracing and visualizing every part of the process to do even these validation exercises that I think are crucial for any classification in general, but particularly for images.
Okay, awesome. So we have a couple questions from Maverick2636. If your evidence suggests a general aversion to violence, regardless of the source of violence within the picture, do you think this effect crossed into political context outside of the US? And related to that question, do you have any references to literature on this topic with similar methodologies methodology in the Middle East?
I am an Americanist, and I am not entirely, to be honest, like all of the things that this is based on is based on repression theory, for example. So Chung is a fantastic reference to go back and like get to know more about like these dynamics in social movements. And the idea will operate similar in other contexts. Like I think there's an assumption here that it will operate in similar contexts because it has some psychological background or like core here to saying like, hey, if you see someone suffering, then you're gonna be more likely to be like, no, I want to be more empathic, or I want to develop some empathy towards you, or I am compassionate. And that's pretty universal. I don't think that's assuming anything about Americanist or like American people, for example. So all of these underpinnings or like concepts underlying this theory are quite universal, but I don't know how they will operate in other contexts. Like everything that I knew and everything suggested that I was going to find these differential effects, and I didn't. It could also be that it's a type of stimuli that I'm using here. Maybe this is affecting this likelihood of participation, but it's not considering other things like just donating for to the movement, for example, right? Like this requires a more active participation of like going to the protest and putting your body there with the idea that you might potentially get hurt. So maybe the question was not, will you join the movement and will you go to the protest, but more like, will you donate to this movement? Or what do you think about contributing in other ways to the cause? So probably it's a combination of, I am not capturing the right outcomes, and I am using a stimulus that really highlights this part of you might get hurt or you might get arrested. So this is just to say I still think there's a lot of truth in the repression theories, or like the thresholds of violence that people can accept and that can mobilize them. I actually think that what happened with George Floyd was evidence of what we were expecting. We saw violence. We saw so vividly how he was tortured and murdered that people activated and were like, I don't care if there's a pandemic, I'm gonna go out. So again, this is just this experiment, for example, was conducted before that happened. So there are still a lot of things to be said, and it would be interesting to see it also in other contexts.
Okay, we have a slightly different question from Anneli Casanueva Artis. Regarding the photos on night, could the fact that less quality photos could seem less at night, like super exposed, for example, and can create some bias for your results? And also newspapers that have less budget for images, they could have different characteristics than those that have more budget. Could it be worth to compare newspapers of the same kind, for example, with more or less of the same budget? I guess the idea is like maybe some high quality pictures are more expensive, and that kind of can bias your results as well. So what can you say about that?
Those are great questions. So for the quality, I had the exact same concern, especially at the beginning of this project. I was working with Facebook data, and with Facebook, the variation in the quality and the size of the pictures was enormous. Like you had a super pixelated thumbnail, and then you had a really high resolution image that was really nice to analyze. And I ran some tests there to see how much my results were changing based on like excluding, for example, the pixelated ones, or creating a version of like a high quality version of that one. And the variation was minimal. However, It really broke when it was really, really pixelated or really, really bad. So in that case, I definitely always had to say, we need to be cautious. Some of these images look more like a, yes, like a thumbnail that was like really bad. And when you run the topic model, you actually had a topic of pixelated images because they were so bad that you couldn't detect what was happening there. But it had to be a really bad resolution. However, for these analyses, because the images are coming from the newspaper from pages PDFs, actually they have a really good resolution. And I checked the variation even between all of those, like the same image, but used by different newspapers. And they all look pretty similar in terms of size and shape. They are normalized and they are also resized to have the same dimensions before this process starts. So that also alleviates some of the concerns. Regarding exposure and illumination and some of those things, there's not a lot that I can do, but I don't think that's the method is very sensitive to those like milder changes. For the second one with the budget, I totally agree. And something that it's related, it's like, well, this newspaper might not have enough resources, but still want to, and I don't know, it's in Idaho, and they really wanted to cover the protest in St. Louis. What are they going to do? They have all of these newswire sources, right? And it could be the question of like, well, maybe they are not even deciding to post the images themselves. They just didn't have a choice because they received one image from the Associated Press. But they actually have some discretion to use them. I'm trying to go to my appendix to show you that in the images they are using, especially for 2014, most of these images were coming from the Associated Press, from Getty, from newswire sources. So there was some, like, we were in a way naturally controlling for that. So I am not concerned about that. With the 2020, there's definitely more variation because the protests were way more local. So you definitely could see that they sent their own photographer and took, like, if it was a little town, it was like a very nice picture of all, like 20 people in the town protesting. So there was definitely more variation there. And I haven't accounted for the size or the budget of the newspaper, but it's a great idea. I'm going to look for that data, like, I don't know, like operating budgets or things like that, to include it. And I also want to include to what media conglomerate they belong, because probably that will also like tap into a bit of that concern. Thank you so much.
Okay, we have another question from Maverick. Did you run heterogeneous effects analysis on the respondents to see if certain groups responded to the picture in different way?
Yes, among race, or like my heterogeneous treatment effect was Black, non-Black, but I have such a small sample. I mean, not small sample, but it's 2000 and I already have different conditions. So I can't believe any of the results that I have there. I mean, I'm not willing to present them and be like, look, there's evidence here, but it suggests that they are definitely reacting differently. So you actually don't see a lot of treatment effects among the African-American subsample, because they already start with really high levels of skepticism about the police. So even if you just give them the text, they are like, no, they went too far. I don't even know what happened, but they went too far. And that's natural, right? Like that's like a predisposition that it's really hard to change. The changes occur mostly in the white sample. So that's it. I already purchased some samples that are like representative at the race level. So hopefully I will get more information about that very soon.
Okay, we have a question in the chat from Sanguin Lui. Amazing research. Would there be any copyright issues or ethical issues you encounter when you use this data? And I assume the question is about images, copyright issues, I guess. I don't think it's about experimental stuff. Yeah.
Yeah, no, and I still, so this paper is still under review, the one with the method, for example. I try to make sure to include all of in the paper in general. Now in the presentation, no, because it would be too too confusing to have a lot of the captions, but I'm definitely crediting all of them. I will still have to probably pay some extra fees if I want to get them printed in the actual paper if it ever gets accepted. But for example, some of the things that I've used, some of them come for the presentation, for example, from Robert Cohen from the St. Louis newspaper, the Post-Dispatch, and I explicitly asked him to use, or like ask for permission to use his images, and he said it was fine. It was even fine to publish them or print them in the paper, etc., etc. So my idea will be to also reach out to them when the time comes for that. But for now, I'm crediting all of them and making sure that there's a full citation to whoever the photographer and the distributor of the image is.
All right, I guess we don't have any more questions in the Q&A or chat.
Oh, and can I say something super quick, Olga? And for the experiment, the pictures that I'm giving to my respondents, those are actually open. They don't have any copyright imposed. That's why I'm using them. And they are also coming from real protest of the Occupy movement. So that's another reason that I chose them, because then there's no deception. Newspapers were using them in different ways, but they were there. Someone published them to talk about the Occupy movement protest. So I didn't come up with them, or I wasn't lying about what happened there.
Okay, pretty cool. Yeah, so I don't think we have any more questions unless someone asked in the last minute, but I want to kind of abuse the host powers and ask my own question. So Michelle, is there a reason why you, I mean, like there's obviously like certain maybe like budgetary reasons, but why you went with unsupervised rather than supervised learning
approach?
Yes.
That's a great question, and I can talk for ages about it. So I really wanted topics. I'm really convinced that the way in which I'm capturing framing is by using this idea of topic in the image, and I wanted distribution of those topics to really make sure that people are not just talking about one thing, one concept that I'm interested in using a supervised method to classify, but to really in this comparison of proportions. So I also wanted to use these prevalence covariates to test my hypothesis. I'm a fan of structural topic models because of that feature of like including and modeling the data generating process. So in order to use that, or to use that approach or that framework, it had to be semi-supervised in that way. Like the supervision comes from the covariates, but I really thought that was the best way to tackle my question. I used the CNN to classify some things, but let me show you that. But the thing is that if I train a supervised CNN, for example, to detect whether there's a crowd or whether there's night, like these two images will have the same outcome, right? Oh, is there a crowd? Yes. If I train a CNN to give me that answer, it's going to be yes for both. But actually, these are very different images in my view of what visual framing means. This one is more focused on the people. One is more focused on the flag, on the identity, the symbolic identity depicted through the flags, right? So then a CNN wouldn't help me that much. Or then I will have to train an object detection model to do it, but then you miss a lot of the things that are happening because it's not going to be able to capture absolutely everything in the picture. So I thought that this approach was the most, like the cleaner and the easier to really capture what I was trying to study.
Okay, that's very convincing. All right, we have, I guess, like a couple minutes for the one last question before we wrap up. And there is one in the Q&A from Jean-Philippe Coinet. Thank you for the enlightening talk. And I was wondering whether you observed qualitatively different visual topics when running STM for different types of protests.
So I haven't done it for different type of protests. This has all been for Black Lives Matter separate from, I also did it for Women's March, for example. And then yes, you for example, don't get the night activity topic there. I didn't did a joint analysis. That one was like with one sample and one sample, with different corpuses. And of course, you observe different topics because, for example, the Women's March, none of the protests happened at night. They were all during the day. So that topic just wouldn't exist. Fire either, because there was no fire, but there was a topic, the pussy hats, the pink hats everywhere, right? So you can definitely find different topics based on the different corpuses. Now I can just give you like that piece of evidence from these two, but I, for example, haven't done it with the nationalist protest or other international protests. I've just focused on these two movements, and you definitely can see different frames there. The one that is really, well, there are two that are like common, and I think among all protests, and one is crowds, and the other one is signs. And I'm expecting to find that one in every single protest that I can possibly use.
Okay, we don't have any more questions, and actually it is our time to wrap up. But thank you so much, Michelle, for such a great talk and all of the responses to the questions. And I just wanted to share some of our upcoming events from Civica, and I want to just thank everyone for joining us today for Michelle's talk. And please, as I already reminded you, that this session was recorded, and you can find the videos on the LSC Data Science YouTube channel, and please join us for our upcoming seminars, the one in 2 weeks in October 20, well, there's going to be like several after that, but yes, the next one after that was going to be on November 3rd. Yes, and stay in touch, and if you want to sign up for our newsletter, you can follow us on the social network Civica Data Science Seminars webpage, and sign up for our newsletter and get more information about all our upcoming events. But thank you so much for today, and yeah, see you in 2 weeks.
Thank you so much, Olga, and thank you everyone for your feedback and your questions.
Thank you.